Well done. Wow. Self-organizing team. It's representative of our robotics discussion. To set the frame a bit, one of the things I'm excited about, what we just heard from Kevin and much of the research you're doing, is bioinspiration to find better, more effective robots. But you know, the thing is, we're talking about our future with robots. Robots are already here. And they're here in more places, in different ways around the world. But I remember, of course, we all know about industrial automation. That's been around for some time. And we all know about the Roomba. Plenty of jokes about that. But I remember almost 10 years ago being in Tokyo. I was at the Imperial Hotel. And there was an older lady in the lobby. And she had a bunch of packages. And there was a little pet sitting next to her. And as I looked more closely, I realized this pet was a robot. And no one was paying that much attention. She was paying a little bit of attention to it as if it were an actual pet. So this stuff is already out there, certainly far more than it is here in Evanston. But what I'd like to do to transition us into this conversation about robotics and our future is ask each of the panelists to quickly reflect on what's your angle with respect not just to the science or the engineering, but with respect to robotics and human interactions. Todd.
Well, okay. So my interest in this area is in many regards focused on how people and robots physically interact with each other. And during that physical interaction, how do they learn from each other? I'm interested in how we can design robotic systems that algorithmically help people learn, but also how should robots interact with people to enable learning?
Great. Thanks, Todd. Dan.
My work in law and technology really focuses on two aspects. And the first is thinking about the governance of technology. And then the second is thinking about how to use technology for legal services delivery and in legal systems. And there's a lot of discussion right now and a lot of funding being pumped into thinking about trustworthy artificial intelligence, fair artificial intelligence, and robotics. And the law has a big role to play there. Thinking about, I mean, usually for lawyers to get engineers in a room, you might have to issue a deposition, right? Engineers don't want to hear.
That might not even work, it turns
yeah, that
out.
might not even work, issuing a deposition notice. But we need greater collaboration in this in this space, right? Because we look at all the areas across society where we have trust and regulation and law governance plays a role. And so there's a huge opportunity to think about how can we be more proactive to think about how greater collaboration here. And usually when we talk about regulation and law, engineers especially are worried that we're putting the brakes on innovation. And I think, though, done well, governance in this space can really foster innovation. And so that's important, not only here in advanced democracies, but around the world. So really thinking about the role of governance, law, regulation.
Great, thanks, Dan. And we'll challenge you with that question later. How can you balance innovation and trust or compliance or all the other issues that relate to governance? Mark.
Well, I'd like to focus on the fruits of the labor of the panelists and Kevin in looking at the macro effects in the future based on an aphorism that Peter Drucker created. I do forecasting and technology, and he said he only forecasts what already happened. And so we can look into the future. Some things are actually very predictable. Kevin, I think you said it's happening. I would say with one divergence from Rob's point that everybody knows what a robot really looks like. It looks like C-3PO. It doesn't look like a flapping machine. I mean, I say that slightly facetiously, but actually honestly, because robots that interact with us on a daily basis, especially in homes and hospitals, will become increasingly anthropomorphic, which raises some interesting there's design challenges. But I would say from a viewpoint of where we are in history, you could say it's already happened. We're no longer in a domain where it's unimaginable, it's science fiction, to have real robots that have much more natural functionality than the clunky C-3PO that's now, 25, 30-year-old imagination. We're on the verge of Asimov's dream as being real. That has profound implications, which I think are fundamentally optimistic for society, fundamentally optimistic for our lives. It doesn't eliminate work, which is where I spend a lot of my time thinking about. And it doesn't create nirvana Right? We're not going to all become poets and scholars and artists because the robots will help us. But I think it's a transformation that we are on the cusp of, which we could talk about more later. It's as big as any that's occurred in human history. Maybe the most recent analog is the dawn of the auto age in 1903, essentially, when Oldsmobile beat Ford to making the first really useful car.
We'll come back to that analog because we talked about it a little bit earlier, and you were comparing it to the internet, the impact of the internet on society compared to the automobile. So we'll come back to that. Mitra.
So I'm really interested in two aspects of how robots and humans interact. The first is ways in which robots might be used to take over tasks to make humans safer. And this is a purely practical applications of robots. For example, robots can function in very dangerous environments and can take over tasks where humans could be harmed. And in that capacity, perhaps animals might, in fact, be shaped not so much like C-3PO, but like animals that excel at particular tasks, quasi-anthropomorphic or animal-like robots. The second thing I'm interested in is I'm interested in robotics as a tool for neuroscience. And the reason is that right now, neuroscientists spend a lot of time recording from different brain structures, but there is relatively little recognition that the brain has a body, and that in order to understand the function of the brain, it's important to understand embodiment and how the muscles and sensors interact with the neural processing. So those are the two components that I'm interested in.
Great. On your first point, Mitra, I'd like to later ask the panel to reflect on, are there situations where we perhaps shouldn't have or want robotic assistance for humans? Brenna.
So my interest is in robotics that is used to bridge gaps in human function, specifically in physical human function that remain as a result of injury or disease. So we already use mechanical devices or even just other physical devices. The wheelchair is a millennia old. Powered wheelchair is getting close to a century old. These already exist in society, but when you add intelligence to them, it becomes a fundamentally different beast in terms of how we design it and how it interacts with humans.
Great, thanks. So good setup. With that setup, I'd like to ground everybody with an example. Kevin provided a number of examples from research related to faculty related to the center. But not everybody has to answer. But is there an example of a robotic system that's particularly unexpected, interesting, exciting, relevant that you might want to share? Any ideas? Mark?
I'll volunteer from a company probably everybody here has watched YouTube videos of Boston Dynamics backflipping robot, and as well as the voiceover with the sardonic robot. If you haven't seen that, you need to find it. But since they've announced that they're now selling or leasing Spot Mini, so the thinking, if you think about a robot that it represents maybe the first general purpose robot offered for sale and by that I mean an ambulatory, untethered robot. So he's targeting as you know, the industrial markets. It's a pretty impressive robot. They're not talking about how much it costs, really, but it's being leased. I think that's a good example of an early entry into a market is targeting safety, to your point, where it roams industrial sites and has a lot of autonomy, as well as interaction with its hosts and its masters. It might be the Model A moment. I mean, if you think about cars are the most complex general purpose machine human beings buy. They have 1,800 unique parts, but 8,000 components and computers in them. There's nothing else all of us buy and use that has to interact with us safely, not kill us and transport us. So it's called an automobile for a reason. So I think we're on a cusp. That might be the Model A. The Model T is
Model T.
the Model A.
The Model A.
Model A, they only sold 1,700 of Model A's in 2 years, and then Ford invented the Model T, and then 2 years later the production line. So it's a decade from the Model A to the Model T. And engineering is just as hard today as then to make complex systems affordable and simple. But the T was the first complex system made affordable and simple, general purpose. Farmers turned them into plows, which gave Ford the idea to make plows separately. So if we're at the Model A, the work that's going on here is what I think enables someone, it's maybe not Boston Dynamics, to make a Model T. And if that happens in a decade, we're very close to the world where the legal parts come in, the interaction with humans, and it's helping some of the elderly carry, if you get injured, but you can still walk, but you can't carry your groceries. That's what Spot Mini can do, and open doors for you if you're infirm, keep you at home with good dignity. So I would say as a specific example, looking at the new videos that they're promoting and their use functions, we have an example, but they're pretty crude. I mean, it's about as close to where we'd like to be as the Model T is, or Model A is, to the kind of car everybody drives today.
Yeah, back in the web days, we referred to that, finding that application that really took off. We called it the killer app. We probably shouldn't call it that this time. Yeah, Mitra.
So I had the opportunity to meet with some Marines who were part of a group responsible for getting rid of IEDs in Iraq, and they had a robot that would help them do this. And I remember how deeply, profoundly sad they were when the robot exploded. It was part of the company, and they wanted to be sure that when they got a new robot back, it contained components of the original robot.
Inverse application.
So, Mitra, what does that tell us about us as opposed to the robot?
Well, so one of the things that has struck me to think about recently is how robots are similar to and differ from pets. So you mentioned the woman who had a robotic pet in the hotel. And I think one of the primary differences is that pets do things that annoy us, but we never think about upgrading our pets, right? We would never get rid of most people would not imagine trading in
Don't tell the SPCA.
their current pet for an upgraded version, and yet we upgrade our laptops and technology all the time. So the point is, pets do things that are annoying to us, and we have to accommodate for our pets. There's a change in ourselves that occurs when we interact with our pets. Instead, when robots, we feel that we should be able to completely control and upgrade to meet our needs. If we had an annoying robot, we might just get rid of it. So I think what was, to your question, what I think had happened in that instance is that the robot and the group of men in the company had interacted in a way that had changed the men's identity or sense of self. Right? The robot had protected the men in very dangerous circumstances.
But doesn't that example then say that they were accommodating for the robots? What we thus do to pets?
In some ways, yes, I think that's right.
Great. Anybody else? An example before we move on? Great. So related to this, generalizing from the discussions we've heard so far, we have a lot of researchers in the room. We have people who are interested in this topic from a practical perspective. What are the biggest challenges that you see facing researchers that if we could figure that out, it would unlock extraordinary opportunities? What is a challenge that if somebody could work on, somebody perhaps in this room could work on that, it could unlock great opportunity?
I know that this is going to come up in a moment, but when people interact with robots, just like when people interact with other people, there's an initial stage of learning about the other. And then with two people interacting with each other, they negotiate their way towards a useful relationship. And that negotiation is a combination of explicit communication and explicit exchange of ideas, In the case of a robot, that might mean that you're directly giving it commands and it's directly giving you feedback. But with people, we're also used to a more implicit side of that communication. And it's something that we're very, very good at. We're very good at interpreting what someone is trying to do. We're very good at interpreting and sort of allocating trust, which is what we're going to be talking about shortly. And that's a very dynamic process. It's not something that happens in an instant, and it's something that I think is extraordinarily challenging to model. That it's hard to model how a person generates deep levels of trust in a robot. And it's also, Brenna and I have worked for several years on this idea of trust being mutual, and that the robot also has to generate trust in the person. And you can think of this, the idea of a driverless car is essentially our expression of not trusting people, right? And so clearly there are settings where we don't trust people and we at least think we should trust the automation more. But that should probably be a dynamic process that's being constantly updated depending on circumstance and depending on the environment. And I think this is a really fundamental challenge for the entire community.
Brenna, do you want to build, what does it mean, the robot trusting us? What does that mean?
Yeah, so I think a good example are these assistive systems, where actually the reason why it exists is because there is some motor deficit in the person. And so if you're trying to keep the person safe, actually you are potentially overriding their control signal in their best interests. And so this idea of whether or not you should be paying attention to control signals that you're getting from the human, which ones you should maybe be discarding, which ones you should be trusting, if there's sort of a history over time of saying that this person tends to get into sort of unsafe situations but always gets out of them, and so actually we can let them do that, versus this is someone who actually gets into unsafe situations and it has bad results, and so I should be taking over control. This idea that if it's a shared control system, that actually the two partners are equal, and it's not just about whether or not humans trust the technology, it's also about whether or not the technology can trust the decisions that the human is making.
Right, interesting. Mark?
Brenna, you had an interesting example, though, of what Tom was talking about. You had an interesting example Todd's talking about, the negotiation process between humans. So you have a negotiation process when your patient is choosing a different modality, different input. Mm-hmm. And it's easy to imagine a much more sophisticated version of that, mm-hmm. right? With the more complex sensors, higher resolution sensors, far more dynamic range. But that sort of smells like a negotiation process.
Mm-hmm. Yeah, absolutely. We actually sometimes call it arbitration. So
Speaking
control arbitration.
Speaking of arbitration and negotiation processes, Dan, how does the law relate to this notion of trust and also enabling innovation as opposed to impeding it?
Yeah, well, I think a couple of ways. So first of all, if you're thinking about humans engaging in a negotiation, we have a framework all around us. We have social norms, we have laws. We know if we make an agreement that it might be an enforceable contract. I mean, our behavior is governed by this framework, and to a great extent, we're lacking that framework in a lot of these areas right now. So for example, even just liability. Liability is potentially an issue for autonomous vehicles, an issue for AI embodied in many different ways. Right now, if you're driving a vehicle down the road and someone runs out in front of you, you'd be held to a reasonable person standard, right? If you didn't have time to react, then you're not going to be held liable for doing that. Well, what's the standard we're going to hold autonomous vehicles to? What if you're a person who's using technology? What sort of standard are you going to be held to as far as if it was reasonable to use that technology? And so there are a lot of questions around this and the role that different liability standards or insurance might play in that whole space. And then I think another thing that comes in with trust, we think about other areas where we have trust, and why do we get on an airplane, or why might we buy stocks in a stock market, or why might we put money in the bank? Well, regulation plays a role there, right? That's part of the trust that we have in society. And so there's been not really a lot of legislation passed so far around some of these areas. And one of the problems is that lack of legislation has resulted in what I would call some knee-jerk reactions. Like, how many people have heard about San Francisco banning facial recognition technology? Okay. Now, to me, that's problematic because, yes, facial recognition technology could be used to do things that we might, as a society, not want it to be used for. but it could also do some very beneficial things for society. If you lose a loved one in a city, for example, you'd want them to turn on the cameras and find that person in the city. But so to what extent are we not developing these technologies now because of the failure to regulate in that space? And so I think we need greater collaboration to think about. There's an act in front of Congress right now. Their attention is not really focused on thinking about Algorithmic Accountability Act right now, unfortunately, but an act that would. Well, so one of the things that's talking about is thinking about how do we create a framework where organizations that are developing technology might be required to do some sort of assessment of the impacts of technology, and that does a couple of things. That helps us ferret out problems and gets us to think about things proactively rather than just reacting to problems on the back end. But then it helps generate this trust in society in the way that technology is being used.
Dan, how could a center like this center at Northwestern engage in that topic? What would be productive?
Being part of conversations like this is great, right? I was thrilled that Kevin invited me to be here. So I think being engaged in this conversation, I have some colleagues from the law school who are here. The Law and Technology Initiative, where there's greater collaboration between engineering school and the law school, and we're doing more and more research that is really interdisciplinary research, and there's really a great need for greater collaboration, and we're starting to see more of that in various universities, and I think it's really happening. The opportunity to do stuff across schools and really partner to see that there are opportunities here to bring a multidisciplinary approach to solving these problems and think about the way that being proactive, putting in place these, thinking not just about ethics, but how regulation and law can facilitate that sort of innovation and building towards this brighter future that we want to create. Right? Those are the things we can keep doing more of that, having the conversations, doing actual research, continuing to engage with people outside the university, all those things.
So an ideal role for an interdisciplinary center, for instance. Mark, quickly, and then I'm going to open it up for questions in a moment, so be ready. But Mark, a quick thought?
Of course, the regulations and laws, as every entrepreneur knows, are important, but they also function as a stifling force if they're done wrong. Yeah. So just history has a lot of examples of these transitions. Certainly the automobile age itself brought all these issues to the front. So there's, as you as a lawyer know, there's lots of case law in new technologies. I would suggest one role for people in this university, in this room, is set with one of the very first safety standards that was ever created. So the boiler standards were created because the invention of boilers really changed transportation, changed heating in buildings. And also at the peak year, I think it was 600 people a year were being killed in boiler explosions. I think one year might have been higher because of the Hudson boiler explosion. So states across the country decided they're going to regulate boilers for safety to not kill people, reasonable thing. The boiler engineers got together and preempted that, formed standards. The beginning of all the standards committees, which are started by engineers and scientists, began then. And it set a precedent that's extraordinarily important to get ahead of the regulators, and then you ask for intelligent regulation as opposed to wait to a disaster and then get something that will not be nice.
Well, to that point, we find that the regulators, the legislators, et cetera, they actually reach out to experts usually and say, what do you think we should be doing? And so if we haven't thought about it, then we don't have a good answer.
Well, they usually reach out after you kill people.
Sure, or so somebody does. Yeah.
Or somebody, or damn. So what you want to do is reach out to them before they have to reach out to you, is my point.
So I want to take quickly for Mitra, a question, a little bit different tack, and then we're going to go to the room for questions. You posed an interesting question in the prep, which is, how do we make a robot curious? What did you mean, and how do we do that?
So, not to nitpick at the praising the question, I think what I initially wrote was, what would it mean to make a robot?
Oh, well, I like my question more.
Not how do we make a robot curious? Because I'm not entirely sure how we make a robot curious. In part because I think it depends on what we mean by curiosity. Yeah. So it's easy to think of cost functions that would force a robot to go out and comprehensively explore an environment in a particular way. But I think something that's a little less clear is what drives, I mean, we've all experienced profound curiosity about something, right? And I think that that's what would be needed to be captured in a robot to really make it, to drive it to be autonomous in a fundamental way in the world. And I don't have a good answer to that question. What precisely would it mean to make a robot curious? But perhaps other panelists have some insights.
Maybe we should institute here, instead of the Turing test, development of the Hartmann test. And you can champion an effort to figure out what that would be.
Not a bad idea. I'll tell you, we became curious probably partly because of survival. We needed to survive. So maybe there's something to that. So questions. And by the way, please attempt to ask a question as opposed to a comment posing as a question. And keep it relatively brief. Anyone like to start? Yes, Jim.
Shout it out.
Shout it out. I'll repeat it.
So my question, we've heard a lot about the possibilities of robotics. I'm interested in thoughts on tempering expectations about what might not be possible. And the example I want to reference that we're interested in civil and environmental engineering, which some of us are starting to work on, is construction automation. Construction is an area that just defies productivity increases. We're not automating in that space. And presumably it's because construction workers and engineers are very good at improvising. So I guess with that example in mind, but I'm interested more broadly in what should we not expect robotics to take over? Should we expect robots to take over in construction, and what other spaces should we not?
Great. Where might there be too much hype, and where should we temper expectations? Todd.
First of all, I think construction is a great example because there are aspects of construction that are being really impacted by automation, right? Like the use of drones to maintain situational awareness over a site. This is something that now is sort of there's a bunch of companies that are doing it. There's a bunch of huge construction firms that integrate into their planning. But it's certainly true that getting a robot to like weld pipes together during a major construction project, this is ridiculously hard. And what comes to mind is, you know, there's a common joke among roboticists that when Deep Blue won the famous chess games, what it was able to do was it was able to plan all the moves. What it wasn't able to do was actually move the chess pieces, right? and the closer that you get to a robot having to do subtle manipulation in an unstructured environment, which is exactly what people are tremendously good at in construction, it just becomes the number of things that you need to be aware of just grows and grows and grows. On the other hand, I think that we are that part of the reason for that is that a lot of modern robotics came out of the study of geometry in the setting of automotive manufacturing. And so there's just this tremendous path dependence that we've been facing. A lot of really good ideas came out of that work, but they also generated a lot of inertia in terms of how we understand what a robot should do and how it should do it. And so my feeling about this is that there's going to suddenly be sort of a sudden discontinuity in what robots are capable of doing, because a lot of that prehistory of robots using geometry to weld parts on a vehicle that's stationary, where everything has been pre-created for the robot to be functional, that's suddenly going to break, and the new set of capabilities will effectively replace it.
But you know, those paths you talk about could also frame different solutions. So just to use the example of construction, we assume we have to go to a site like they did in the Roman Empire and start from scratch and put a bunch of 2x4s, which aren't 2x4 by the way, together on site. And we've had these modular solutions for a long time produced off-site and then moved in, and they were always for low quality, low cost, junky solutions. It could be that things like the path dependency from automotive actually allows us to do much more effectively modular work in a factory setting and then move those things to site, for instance.
Well, and I'd like to just add, here at Northwestern, there's a group probably in the audience working on construction of sites on Mars. And in that setting, this idea that what you do is you need the the automation to be matched up well with the construction technique. And so they're doing both things in parallel, and being willing to change your entire approach to construction may be necessary if you want to be able to automate the construction of large buildings.
Great.
Just quickly, the situational awareness that's up close, the future's already happened. And between whiskers and electrosense, the biggest problem robots have in a complex environment is you can't use vision systems with a NVIDIA GPU. It has to actually sense the environment at its very high level of resolution and texture. It's clearly possible now, and so you end up with, to your point, a new class of robots, which will take on the two most intractable parts of our economy that have no productivity change in 25 or 30 years, which is your sector and healthcare.
Yeah, up here.
So I'm going to riff off what Todd mentioned in the first question. So bioinspiration is a really great idea, fantastic direction, but it's one of those things that's going to be a bit more farther in the future in terms of actual practical stuff. Today, humanoid firefighting robots that you try to field on Navy ships, they run for an hour. And if you saw the outtakes of the DARPA humanoid robot competition, it's truly sad. And a lot of that is materials, right? So how do you A, get the material scientists engaged more in helping revolutionize that faster? And B, in the meantime, what do you do to work around that?
How do we get material scientists engaged more, and perhaps other fields engaged more, and how do you work around that in the meantime? Any thoughts?
Robots eat too. They need fuel, and there are no clear paths to better fuel, so the path is to lightweighting and hyper efficiency in the control systems and better motors, which are all material science issues. I think the future of robotics is 90% materials now, because the path to better AI is, it's hard. I'm not trying to underplay the brilliant AI people, but that path is clear. Materials path science is really difficult and critical.
Brenna, you work a lot with people in other fields, in medicine, for instance. How do you get them engaged?
So I think that we can take examples from some innovations that are happening in medicine. So for example, when we think about different materials that are used as substrates within the body, how you can 3D print tissues now, essentially. Things like that are innovations that happened because we needed better biocompatibility. And so if we take Ken's example, that the fact that humans and other animals have been interacting with the environment and they've developed materials that are capable of that sort of flexibility. I mean, we don't have anything like the human skin that's waterproof and can sense, and all of these sorts of characteristics that it has, we don't have anything close for robots. And so if we take as sort of inspiration that, and then the innovations that have happened because it was necessary for human health, but we can maybe translate those over into the sphere of robotics.
Don't you think if we can articulate the challenges that robotics fields are facing in the terms of a material scientist or in the terms of a cognitive science or whatever, you can perhaps get a better engagement and better outcomes? Anyway, someone else, all the way in the back.
Hello. Kind of along those lines, at the very end, you had this graph of the robotics branching out to collaborate with different groups. I was wondering, how are you trying to collaborate with different groups inside of McCormick that aren't traditionally a part of robotics?
Maybe that's Kevin's.
Kevin, anything? You thought you were off the hook, didn't you?
So we're certainly involved with material scientists trying to develop better materials for sensing. And I think the Material Genome Initiative will be an important component of further development of robotic systems.
Great. Yeah, right here.
When you talk about materials, are you considering environmental concerns in inputs, outputs, and processes?
Robotics, materials, environmental concerns. How does the environment play into this question? Any thoughts? Todd?
So I think one of the things that's complicated about our assertion that what we often say is that robots are supposed to do things that are dull, dirty, dangerous jobs. And as soon as you're talking about something that's already dirty and dangerous, that often means that you're not so worried about what you might do to the environment, right? You're worried about, we have the nuclear reactor that has already started melting down. And so like at that point, we're past the question. I think as robotics becomes more ubiquitous, the impact of particularly, batteries are a very dirty technology to manufacture. And right, I mean, there's lots of things that when you build the robot, there's a lot of energy that gets expended during the building of it. There's a lot of energy that gets expended in making the batteries. And you're doing all of this for something that at the end of the day doesn't have very much power density. And so, as we've already said, it doesn't last very long. And so these trade-offs, I mean, in a lot of ways, we just aren't even to the point of being able to explicitly make the trade-off because we're just so bad at manufacturing robots in a clean way and having them be effective at all. Like both of those things are separately already hard, that it's not sort of part of a natural optimization that takes both into account. But I think most people in robotics are worried about this. I mean, the number of people who work on robotics for environmental monitoring, where they're not worried about what the effect that their robot is having, but they're certainly interested in, do the robots provide better data about what's happening out in the environment? Like this is something that's very visible to the community. And so the question is, what will happen as the number of robots that are deployed on a given day goes up and up and up? How are we going to eventually, what will be the threshold for suddenly deciding now we need to worry explicitly about the production of these robots and what the impact of that production is on the environment?
Brenna and then Dan.
And I think also that thinking about the cost of computation, the actual environmental cost of computation is something we're going to need to be thinking about. And this is not exclusive to robotics, but if we want robots to actually be adapting to their environment, taking in enormous amounts of data and being responsive to that, it's going to take a lot of computational power to handle that data. And so I think, we've just only recently the amount of computation that goes into cloud computation and the use of things like Amazon Web Services just recently surpassed the carbon footprint of flying. And so and the advances that we see, some of the advances we're seeing in robotics are because of arm farms, these rooms full of robotic arms that just run 24/7, and they gather data and they learn from that. And that's not just the cost of powering the arms, it's actually all the computation that's happening off board as well. And so, getting back to the idea of materials, we don't have anything that's anywhere near as efficient as the human brain in terms of energy expenditure. And that probably will be a factor we need to pay attention to as well.
Aside from some people's human brains. Anyway, Dan.
Yeah, I was just going to highlight that this is another example of the need for interdisciplinary work, like getting more economists, getting people in the law school, getting people in Kellogg involved, and thinking about these things now, because there are a lot of case studies we could point to. Look at genetically modified foods. They're prevalent here in the US, but in Europe, almost non-existent. And a lot of that had to do with the failure to think about some of these issues ahead of time and prepare the public, prepare governments for the benefits of genetically modified foods. So we don't want to see the same things here, where technically we can do things, but governments and the public aren't supporting them, aren't helping push the innovation forward. Even I don't want to compare Bitcoin to robotics, but look at all the pushback for Bitcoin for a while there, because of the concern about energy needs, and we need balanced studies of what are the benefits, what are the costs of the current status quo.
Well, I'd like to offer the contrary, the opportunity. Someone mentioned space. So the Chinese are very clear, very, very aggressive, very public about their very aggressive plans in space. And their first full phase of having an active colony on the moon, they've decided the moon needs to be first, and I guess we chose Mars, was all robotic. They said, we're going to focus on automated systems for a very long time until we start to send people on a regular basis up there. And that's simply an question of efficiency and effectiveness. And it's far more energy to send one of us up into space and deal with all of our unfortunate needs. Any other thoughts before we I have a couple more questions, and then I guess we'll conclude.
Well, let me do a macro on the environmental question, because by the way, you're right, incidentally, the global cloud, the book that wasn't up there, my next book is Digital Cathedrals, which comes out in a week. It's about the energy. It's looking at the information infrastructure through the lens of its appetite for power. So AI is, to computing in energy terms, equivalent of going from a bicycle or scooter to an SUV. I mean, it's a profoundly more energy-intensive way. And you need AI to make computing work, and which means to make robots work. Robots will only be used because they're more productive. I mean, full stop. There's no, except for the military, and even there, it'd be more productive for their purpose. And that has always meant, this is, I'm stealing Joel Moycure's line, the lever of riches, which was a delicious title for his book.
Great book.
It always, always means greater productivities, always means more wealth. More wealth is the strongest correlator to cleaner and safer environments, always, every country, every time. So at the macro level, I'm extremely bullish about the impact, because when robots do finally become useful, they'll be profoundly productive machines, create more wealth. People then can implement their wishes, which are expensive. To make the environment much, everything we want to do to make things safer and cleaner costs money. This generates wealth and makes that possible. So I'm very optimistic about it long term. The transition, we got to get good at making these things. It's not easy.
Yeah, so you're all five immersed in this space in different ways. We're obviously interested in it, or we're accidentally here just if I was to eat free food or something. What should we be paying attention to? What is some development? What is some news source? What is somewhere we should be paying attention to see some of the leading indicators or see what's important, where things are trending? Todd?
So we have this conversation with the Master of Science and Robotics students a lot. That
Great.
what should they be looking at? What should they be paying attention to? And the two things, first of all, I think looking at how not just the legal system responds, but also how society at large responds every time someone dies. Right, like it's not happening very often, but when it does, I think figuring out what tolerance people have for automation and AI-related injury and death is a really good way of thinking about like what's going to be possible at a society level in the future. And that sort of related to that, every time you see a startup company that's doing something that you can think of a huge company that has a ton of infrastructure that would allow them to enter that space, asking why they aren't. Right? Like, what is it that that big company sees as a risk? And it's, sometimes it might be inertia on the part of the big company, but sometimes it's that they're genuinely worried about something. And so I think in terms of understanding, like, why are different players thinking about their decisions in different ways? Startup companies have the great advantage that at the end of the day, they produce something and then they go out of business and they're done. Huge companies don't have that same luxury, and I think that you can really see it in their decision making, specifically in this space.
Yeah, we could talk a long time about that. Other thoughts? Where should we be looking, Dan?
Yeah, well, I think that we're not investing enough in the U.S. in this space. When you look at the investment in China, for example, just in comparison, we are not investing enough in this space. And as far as public acceptance, I think we need to think more broadly about education. In universities, including in law schools, we should not be graduating students who don't understand this space. But we also just should be thinking about educating the citizenry more generally, right? People need to understand that. I think that's one huge problem to acceptance and trust, and getting people to understand if systems are fair is just, they need to understand this. And so how do we better educate people everywhere about these tools?
Yeah, and the ethical decisions become far more front and center and poignant. Mark?
I'd stay on that thesis, and the bellwether I would look for is when the industry, small and large, and the researchers get ahead of the curve on both ethics standards, codes of conduct, and preemptively coming up with the class of regulations that are needed. And there's some work like that going on, but not enough, and it's not vigorous enough. And since we're now on the cusp of robots that are, well, you have one, Spot Minis going into your business in the construction field. Odds are it won't hurt anybody, but it could trip somebody, right? I mean, this community is the one which will be the bellwether that will matter, because if you get ahead of the issue of people will die, people will get hurt, they're machines. And you want to be ahead of it, not behind it. So I think a bellwether that's positive is when this community is more aggressive about doing that, which includes the innovators, the tech companies, Silicon Valley, engaging in what amounts to voluntary self-regulation.
Yeah, great. Other thoughts? Where do you look for where things are going?
So I think an emerging field that's particularly interesting is soft robotics and the control of compliant joints and use of fluids to control different robots in the world.
I would be looking at windfall from the automotive industry. So the investment by the automotive industry in autonomous cars or just in driver assist technologies is probably the biggest investment that we've seen in robotics, period, perhaps with the exception of the US military. I don't actually know the numbers. And what that's going to mean in terms of both the robustness of the technologies that get developed and the falling cost of things like sensors is going to have impact on other domains that previously did not have the market share to actually think about robotics technologies as something that could be a solution for them. And so I'd be looking for that.
To underscore that and to tie it back to your point, Todd, about 4 years ago I was interviewing Carlos Tavares, the chairman of Peugeot Citroën at the Frankfurt Auto Show, and he said, remember this was 4 years ago, so he said at that time, Professor, 3 years ago, none of the big automakers were paying any attention at all to self-driving vehicles. And today we're all scrambling to try and catch up, which has translated into literally billions of dollars of investment. This might be the first time I'm aware of in history where an entire industry was pre-alerted, they weren't fast enough, but pre-alerted to the fact that they have an existential crisis coming, even though the numbers right now of performance aren't bad. So there is some dealing with disruption already going on. Whether it's enough, we don't know. So we're coming up toward the conclusion, and we want to make sure we get to go and play with all the baubles and see all the examples over at McCormick. But what's something, and not everybody has to answer, but is there something that any of you have seen in the past year or two that was unexpected to you, where you said, holy cow, I didn't think we were going to see that for 10 years or ever? Anything unexpected that was particularly interesting to you? Because you're the experts. If it's unexpected to you, I want to know about it. I guess you guys know everything. All right. Now, anything?
I was surprised by Boeing and the 737 MAX. I was deeply surprised and disappointed by that entire event.
That was a space shuttle organizational dynamics failure, full stop. Anyway, any other thoughts? Okay, one last question. Robotic apocalypse, yes or no?
Rise of the machines?
Robot apocalypse, true or false?
False.
False, okay. How many true?
Great science fiction. I mean, it doesn't get better than that.
I think it was Andrew Ng when he was asked about this. He said that it's a problem we should be worrying about, but it's the same kind of problem as like overpopulation on Mars, right? Like, it's like, yeah, I mean, we've got bigger things we should be worrying about. So I say, yeah, no robot apocalypse.
Okay. Todd?
I think going back to what Ken said, the robots need to be able to open doors.
Okay, all right.
Spot Mini can open doors.
And not fail if you throw mud on its sensor.
No, that's true. No, actually, that question falls in the category of, I think one of the questions was about hype. So that's in the hype category, and a lot of the things that have been said about AI are deeply over-enthusiastic, way out over the skis, and robots will, I think the AI hype is going to go back into an AI winter probably now, because it's been so overpromised, and we run the risk now of robots going into the classic hype cycle.
I think I saw a grimace over there too. You want to respond to the hype cycle comment?
Well, I mean, I think this is what a lot of us worry about. That we are at a stage now where there's a whole set of things that work so much better than they did 10 years ago, and that there's a tendency even like within the robotics community, when people are talking about their own work, they tend to want to talk about it in this anthropomorphic way that really encourages overblowing what has actually happened. Yeah. And instead what that does is it undermines the statement of what's been accomplished, and then leaves the listener with the sense that all of these impossible things are going to just immediately and easily happen. And so I think like it's a huge risk for the community right now.
Yeah, great. Quickly, one last question.
Congratulations on the new center. What is your vision for the center in 5 years from now? If you had your ultimate dream come true, where would you like this new center to
Kevin, do you want to field that briefly? Why is it a machine? And then we'll conclude.
Okay. Well, so first of all, thank you to the panelists. That was great. So the core of the center's research has always been science and technology, and you saw some of it up here. And 5 years from now, that is still going to be the core of what we're doing. But really, one of the main purposes of launching the center was to ask some of the questions that have been bandied about here today. So my dream for the center is that some of those roots or tendrils that you saw reaching out to other parts of the university will actually happen. That we'll have a joint research project where we're coming up with some new, legal standards, and they need some expert input on to what's actually possible and what will be possible in 5 or 10 years, and that's something that the center can provide. So my view, certainly within Northwestern, because Northwestern is a very interdisciplinary place, it's very supportive of this kind of activity. We want to take advantage of that and really reach our roots out into the other schools and departments around the university. So that's my number one goal. And then of course, we're in Chicago, and Chicago is a bit of an untapped startup market in terms of in technology. And so I think that there's a lot that we can do in the center to cooperate with places like M-Hub or 1871 to really, take some of the technology that's being developed in our labs and get it out and make Chicago a place where people stop instead of flying over from coast to coast in technology.
Kevin, let me underscore that a little bit. My colleagues overseas, startup entrepreneurs, venture capitalists, et cetera, they tend to go to Silicon Valley and open an office when they want to expand. And then they realize a year later they're spending all their time on flights coming to Chicago or going to New York, because that's where the customers are. The large corporations, especially if you're in B2B situations, the large customers are not in Silicon Valley. The people in Silicon Valley are the 4 people that no one at headquarters listens to. And so you got to come to Chicago to talk to customers. So especially if you're in a B2B environment, there is enormous potential here and a lot of corporations that are eager to talk to you. I'd also recommend, if you have something to offer to this center, you know what? Just show up. It happens because people connect and they start doing projects. Just keep showing up until they kick you out. So we learned a lot here today. Mitra shared with us that Marines care about robots. I didn't know about that. And we accommodate for our pets. I'd say actually we'll be accommodating for our robots too. There was a beautiful program back in the 60s called ELIZA, and it was a hard-coded, it wasn't even really Go-Fi. It was just, felt like an automated therapist. You can look it up. And it would do things like, regardless of what you typed in, and it was all green screen, it would say, how does that make you feel? Tell me more. The sort of things that your spouse or significant other might say to you when they're not paying attention. But one of the interesting results of this experiment was even the people who knew it was not responding to them in any meaningful way felt attached to it, wanted to interact with it and use it as a therapeutic device. And their eyes were apparently wide open. They're learning about the other, Todd. We're creating things to learn about and to learn about us so that we can be better together in subtle, unstructured environments. What are the questions we should be asking? And to the question that you asked, Ken, how do we better craft questions to engage other people in helping us come to solutions? How do we, as Dan said, engage in these conversations before they're a crisis? How can we be ready when that crisis happens with productive answers for everyone? And Mark, this might be the Model A moment. Model T, Model A, one of those moments. Pretty exciting. How do we, in this moment, leverage the fruits of our labors, the fruits of these labors, the fruits of these robotic labors as they increasingly will be, enabling us, Brenna, to not only regain functionality that perhaps have been lost, but your work actually can help us be better and more effective than we have been with our physical traditional systems. In the shared control systems environment, ultimately, it's not about the robot apocalypse. I think we all agree about that. But there's another reason why, and it has to do with the work going on up here in the center and all around the world, and that is the interface and the interaction between human beings and robotics and artificial intelligence will become increasingly melded together. So what will it be? It won't be us against them. It will be us against us, or us for us. Thanks so much for our panelists.